Hi students, these are going to be your notes for special right triangles. So for this unit, we're going to learn all about triangles. And your book doesn't really cover these specific triangles, and I find it really important that we go over them because it really will make this term much easier. We're going to use these really throughout the entire term. So it's going to be just like a quick little thing, and then your homework is actually going to be a worksheet that you'll submit. It will not be in my math lab since it's not covered in the textbook, but I'll send more information on that. So here is a special right triangle. The reason it's special is because it has these specific angle measures. And if you remember, triangles have to add up, all the angles have to add up to 180 degrees. So if I had a 44 degree, 46 degree, and 90 triangle, that would not be special, okay? It has to be a 45, 45, 90. And if you played around with these triangles enough using Pythagorean theorem, you would see this formula come about. But to save some time, so I'm going to create a triangle that hopefully looks like it has equal length legs. And this is 45 degrees, and this is 45 degrees. So I have a 45, 45, 90. And if you remember from geometry, and if you don't, that's okay, that's why I'm here, across from the same angle is the same length leg. So, I don't know what these lengths are, but if that is x, then this has to be x. Does that make sense? And then this, remember, across from your right angle is always known as your hypotenuse. So I don't know what that is, so I'm going to label it y, just something else. It can't be x. And if I use Pythagorean theorem, x squared plus x squared equals y squared. And let's isolate the y. So I have an x squared plus another x squared, so I have 2x squared. And if I want to get that y alone, I would go ahead and take the square root. Well, what happens there, some good old algebra coming back, is I can't take the square root of 2. I'm a little bit stuck. But the square root of x squared is x. Okay, so what I found here is, I'm going to go ahead and take away this y, that the formula is you take whatever your length leg is and you multiply it by root 2. So what am I getting at here? If I gave you a triangle, and I'm going to claim it's special, so it has that 45, 45, 90 degree measurements, and I'm going to just make this up. This is a 4. I want you to find the other two missing sides. Well, you could rely on Pythagorean theorem, but the whole point of learning a formula or a pattern is to make your life easier. So then you can figure out things much quicker. So if I know that's 4, well, this has to be 4, and hopefully you feel okay about that. Well, based off this formula and really how the math was shown, I don't have to do any work. Again, we can do Pythagorean theorem to prove it. But what happens here is that, okay, well, if my legs are 4, that means my hypotenuse has to be 4 root 2. So you found the missing legs without doing any work, which is really nice. Okay? So if I gave you something like this, so I have 45, 45, 90 degree. So I don't really have to mark the other angle because it has to add up to 180, so that third angle has to be 45. And let's just say I'm going to make this be 6. Well, now I want to find the legs. Well, when we went from here to here, we multiplied by root 2, right? We had our hypotenuse, hopefully this makes sense. Your hypotenuse is always the longest side of your triangle. So if I'm going from my hypotenuse to a leg, I'm going the opposite way. That means you would divide by root 2. So this is 6 divided by root 2. Although, good old mathematics, you cannot leave a value like that. And that is because dividing by an irrational value is very challenging. So it is common practice, and you will do it in calculus, where you have to rationalize this fraction. And so what you have to do there is you take this and you multiply by root 2 over root 2, because you're multiplying by 1. And hopefully this is familiar. I think this is like covered in, I'm totally trying to remember, like Math 95 or 65. And you end up getting, well, 6 times root 2 is 6 root 2. And root 2 times root 2 actually gives you root 4, right? But what is root 4? Oops, I don't need to write it again. It's 2. And then your very last step is, what's 6 divided by 2? 3. So your side lengths, or your legs, are 3 root 2, and your hypotenuse is 6. So another way you could do that is, and only use shortcuts if they make sense in your brain. If they don't use them, because then we start making things up. What's 6 divided by 2? Well, 3. And then you slap on that root 2 on the end. So that will happen every single time. So what I'm getting at here is, we're not going to do this whole sheet, but if I look at just one, because this is a 45, 45, 90. Okay, and let's look at 3 as well. Let's look at 3 first, because I think it's easier. Well, I don't have to do any work, okay, because I know this formula, and not that you have to have this memorized yet. In time you will, but use your notes while you're doing things. Okay, well, if that's 12, that means this leg has to be 12. And then I can use Pythagorean theorem. That's always an option, but I want to make you become confident in these, and also just do these very quickly. Okay, well, if that's 12, this guy has to be 12 root 2. Okay. Where on the end, I should be consistent and give myself units since they're giving us units. Where our 1 is that other way. Well, now I'm going from hypotenuse to leg, so I have to divide by root 2. Well, I can't leave it like that, so I have to rationalize it. And here's the shortcut. What is 12 divided by 2? 6. Slap on that radical on the end. And again, only use that if that makes sense. If it doesn't, then you have to go through it the long way. Let's see if I have any more down here. 45, 40, no, okay. So I'm just gonna stop the video there, because that takes care of your 45, 45, 90 special right triangles. That's how we refer to them. And your next video will be on 30, 60, 90 triangles. Now remember, you can only use this formula when you have these angle measures. If you don't, you're stuck with Pythagorean theorem, or there's something else actually out there that we'll learn in section 7.1. All right, bye-bye.